I would now like to turn to the topic of climate resilience. Whether we manage to actually mobilize ourselves to achieve net zero within the next 3 decades, our climate is already changing in alarming ways that we can all see and feel. And so all of us in our everyday lives are already making changes that are large and small to adapt to the changing physical reality that's around us. Now, of course, many of the people here in this room, what we're coping with really just amounts to lifestyle inconveniences from the changing weather. But more and more people across both the global south as well as north have to flee climate change-induced devastations, or they risk losing their lives or their livelihoods. So in this next section of our program, we're honored to welcome Dr. Sarah Kapnick, Chief Scientist at the United States National Oceanic and Atmospheric Administration, who will speak with us about what we're seeing now and what we can expect when it comes to the physical risks that we all face from climate change. And following Dr. Kapnick's remarks, she's going to be moderating a conversation with 2 panelists about how private sector investors might be thinking about resilience in a different way in a warming world. So let me introduce Dr. Sarah Kapnick. She is only the 3rd woman to serve as chief scientist in the 53-year history of the U.S. National Oceanic and Atmospheric Administration, or NOAA. But she is the first to also have worked on Wall Street. Yay! Dr. Kapnick rejoined NOAA in July 2022 from JP Morgan, where she served as senior climate scientist and sustainability strategist for asset management. Being named chief scientist marked a return to NOAA for Dr. Kapnick, who previously worked at NOAA's Geophysical Fluid Dynamics lab in Princeton. There, her work included research on seasonal climate predictions, water security, and the market impacts from climate change. As chief scientist at NOAA, Dr. Kapnick sets the policy and the program direction for NOAA's science and technology priorities. And we, of course, love many things about NOAA's program direction, but the one that is the closest to our hearts at MSCI Sustainability Institute is Dr. Kapnick's commitment to improve access to data and to be developing measurements that can help bring climate risk into decision-making across many more facets of our economy. This priority mirrors the work that's underway at MSCI Sustainability Institute to be equipping more researchers with the climate data, metrics, and models that are used by financial institutions. So under Dr. Kapnick's leadership, NOAA is, for example, developing models to better understand the carbon cycle and extreme weather events as they unfold. And this type of work is increasingly relevant to all of you here in this room because they really inform the climate risk financial models that are used by so many of you and will need to be improved over the next 5 to 10 years. So she received a doctorate in atmospheric and ocean sciences from UCLA and a bachelor's in mathematics from Princeton. Please help me welcome the chief scientist of the U.S. National Oceanic and Atmospheric Administration, Dr. Sarah Kapnick.
So thank you for that wonderful opening, and I'm so excited to be here today to talk to all of you. NOAA's mission for all of our science, for those of you who aren't aware of it, is from the surface of the sun, space weather coming off of the sun to make sure your satellites and your grid are operating on time and properly, all the way to the bottom of the ocean where we're mapping the ocean floor and also doing ocean exploration. It covers constellations of satellites, observations, we send balloons up into the atmosphere. We cover the oceans, understanding and monitoring the oceans, ports, marine transportation, fisheries, marine protected species of biodiversity, weather and climate modeling, forecasting, and we also have a fleet of ships and aircraft run by one of the 8 uniformed services of the US government. Our technical support and capacity building efforts through all of these programs, particularly in local communities, through Sea Grant, which is the Ocean and Great Lakes version of Land Grant, as well as climate adaptation partnerships across the nation. We have offices in every single state, every territory, and even Antarctica for over 60 years. So as NOAA's chief scientist, I get to cover all of this science, and I'm responsible, as you said, for advancing our policy and program direction. But also, you may not be aware, NOAA sits under the Department of Commerce. So our job is also to ensure that the science and technology that we're producing is advancing commerce in the United States. I also, in my role as NOAA Chief Scientist, as one of the most senior climate scientists across federal government, is to also advise other federal agencies needing our science and needing that science for decisions. So, with all this information as the scientist, but also this expertise with finance, it's really allowed me to have a unique focus for the Chief Scientist role. In particular, I have been working on how to make climate information more actionable for a wide range of stakeholders, especially when it comes to understanding physical and biological risk and opportunities to enhance resilience. I'm working to bring more climate information to bear in financial decision-making, especially when it comes to new technology investments and capital investments for environmental markets such as carbon markets and biodiversity. We are trying to ensure that there is science brought into these groups and that we are supporting that science and technology that needs to develop for the future. Without good information, we risk maladaptation. That might be a new term for people. This is when you make decisions poorly on adaptation. You think you're doing something good and it actually makes things worse. So we can miss opportunities to create jobs and economic opportunities, increase community and financial resilience, and demonstrate global leadership if we don't do this right with science and technology at its core. As NOAA's Chief Scientist housed in the Department of Commerce, I also see our science and technology advancing the future of the entire economy as we deal with climate change. As the world responds to climate change and environmental considerations, every single sector will need to respond. Through our historic investments in the Biden-Harris administration, through BIL and IRA bills, we are advancing the development of the climate economy and driving innovation and key solutions that the world also needs. And NOAA is also working across all of Department of Commerce to inform on climate and science and technology. For example, IP in the US Patent and Trademark Office of how you advance and fast-track climate patents. Also, trade policy on advancing science, the use of science in industries around the world. So, what does this room need to know about climate science? Bottom line, I want to tell you that, as was stated previously, climate change is creating risks for all current and future assets, and we know enough, but we also know enough to be able to take action to both mitigate the future greenhouse gas emissions that are driving these warming trends, but also we have so much information about what the future holds to be able to adapt and build resilience to all these impacts already baked in. And to offer some color in the statement, in recent years, the US has experienced an unprecedented rate of billion-dollar weather and climate disasters. NOAA is in charge of maintaining this database since 1980. To date this year, we've already seen 23 confirmed billion-dollar disasters across the United States. This is the largest number that we've ever seen in the first 8 months of the year. Additionally, every month, NOAA provides updated information on the state of the climate in the United States and worldwide. Last week, we announced that August was the hottest August on record in 174 years. Now, I think people are starting to get desensitized to us breaking these records. And I will say that normally we break these records by 1,000th of a degree. We broke this record by 0.5 of a degree. And so we broke this record by so much more than we ever have in the past. It left our data scientists shocked. They were saying these comments of, I never expected I would see this now. So climate scientists are a little bit worried. I will also note that this is also happening as we're starting to head into an El Nino. This really matters. So we have climate change increasing temperatures over time, but El Ninos are also the wiggles around that. And so an El Nino will push global temperatures up by 0.1 degrees on average for an entire year. With that, and of note for some of the prompts today, El Ninos also drive warming in individual months above that. Our seasonal forecast from last month showed that over this winter, we may actually exceed 1.5 degrees of warming in individual months in the next few months. So this winter, we may have a few months that may exceed 1.5. So the Paris Agreement, when it talks about 1.5, that's over a many decade average. It's not an individual month. But still, it's very sobering to realize that we are starting to dance with 1.5. It's also important to remember that with the heat extremes, with the extremes that we've seen this summer, with continued climate change that we expect, this is actually going to be a cool summer in comparison about a decade from now. Also, with an El Nino developing, there tend to be more extremes and there tends to be more heating. It also is a glimpse into the future of what the future holds for us when we're seeing these events. The current climate trends will significantly increase population exposure to heat waves, heat-related morbidity and mortality, and that risk is further compounded by urbanization, demographic changes such as aging population, and other stressors such as migration, conflict, disaster response. Extreme temperatures and precipitation also have consequential impacts on physical assets, disrupting supply chains, and impact utilities' ability to provide pulses in demand and energy security. I sit on also the National Academy of Science Macroeconomic Climate Risk Roundtable. The main work of myself and other government officials and academics is to accelerate the integration of climate information into macroeconomic forecasting. That's really for also budgeting in the US government. The main difficulty I see in this so far, why it hasn't happened, is it requires translating science into the economic impacts. And I think that is where I am so excited to be here for this institute today, is this is a critical stage for us to start translating that climate information, the physical information, the biological information, to what it actually means for the economy. To make this more tangible, I thought I would give an example of the insurance sector. We are closely speaking with the insurance and reinsurance sectors. We've held another number of roundtables. We've seen recently that insurers are starting to leave some markets. This decision is both due to physical climate risk and the actual physical damage they're seeing, but also due to inflation. The two together make it too costly to operate companies that could handle one or the other, but not both. For the past 2 years, we've been engaging with them regularly and hearing what type of climate information is needed. As part of our commitments to service delivery in this space, we've conducted multiple engagements across the industry to find mechanisms to build a response to the pressing needs. The top one being for us is that we are working with the insurance industry to bring climate information into catastrophe modeling with a new public-private partnership that we've set up with National Science Foundation. In this, climate information is being incorporated now, but it is coming at a time when people are already starting to access the market because they don't have that data. The goal going forward is to try and accelerate that, bring climate information into catastrophe models, and also build the future of the workforce that can handle this type of work. Another example I want to give is of energy. We've been working with EPRI on building a climate-ready nation around energy. This is both for operations of how to deal with weather shocks, but also investing in the built environment. As we're seeing all of these investments made into decarbonization, there's also a need to think about adaptation now for smart, efficient investment. And so we're seeing this also at the intersection of the energy sector and insurance. Increased costs of hail and severe storms has led to increases in insurance costs and problems with solar power production this summer. This past summer, we also saw wind droughts due to multiple heat domes coming across the United States and damping the power production, which led to losses in commodities and markets and wind producers, and a lot of interest in what is the future of wind. So how can science be used by investors? To wrap up, I want to say past conditions, the historical information that we have, is no longer a reliable indicator of future conditions. Therefore, when making decisions and planning, it's imperative to start incorporating climate projections into this process. We have the science to actually look into the future, and we need to start incorporating that into how we do our operations. Building resilience isn't also just about climate anymore. It's also about being able to deal with compounding risk factors, of which climate can be one, but can be one that amplifies other risk factors. As people recognize the risks of climate change, this also creates opportunities for innovation and the build out of a climate-aware economy. So I talked about a lot of stuff that I'm usually the downer at the cocktail party when I start talking about the science. But if you start thinking about what is going to happen when we have climate-related shocks and scarcity, there's going to be innovation. People are going to try and come up with the climate solutions to adaptation, to building resilience. And that new demand for those solutions, that is where the innovation comes from, and that is where the investment opportunities will start to develop. So we are faced with this climate challenge, but this is physics. We know what the future holds. And so now it's a matter of figuring out where are those opportunities, investing in adaptation, resilience, and we are really excited to be NOAA to be here to give that science and technology out to try and support that further development of the markets, but also the new technologies that need to exist.